Okay, in question number 26, given is a particle of mass m at rest. So initial velocity is 0 and at origin at t equals to 0. So x is also 0. It is subjected to a force F naught e to the power minus bt in x-axis. So the speed depicted by which of the following curve, right? So for velocity, you need to have velocity will come from acceleration will come from force. So we will write force equals to F upon m, F naught e to the power minus bt upon m. Then you will write a dv upon dt and take dt on the other side where the t is there. So F naught upon m e to the power minus bt into dt. Now put integration on both sides. Limit of time will be from 0 to t and limit of velocity will be from 0 to v. So left hand limit will come v, right hand limit F naught upon m e to the power minus bt, and the coefficient of t, that is minus b, will go into denominator like this on integration from 0 to t. On solving this, if I take minus sign into the bracket, then the limit will change. So I will first put 0. So e to the power 0 will become 1 minus e to the power minus bt. Now how is the function? This is an exponential function which is increasing in nature, right? At t equals to 0, when you put t equals to 0 in this equation, you will get v equals to 0, right? E to the power 0 will be 1, and therefore at t tends to infinity, v will become F naught upon mb, because the second term will become 0, right? So we see that the maximum limit of the velocity is like this. So the answer would be either B or C, okay, because both are going like this. Now in this actually in main question, one of the options has this axis written as F B naught B upon m. So in that case, B will not be the answer, C will be the answer, right? So in main question, here is a correction. In question number 34, initial speed of bullet from a rifle is 630 meter per second, and the rifle is fired at the center of target 700 meter away from at the same level as of target. How far above the center of the target the rifle must aim in order to hit the target? So basically this would be the path of the bullet, and this is here where the target is. How much away it is? It is 700 meter away, and this is how it is being fired, 630 meter per second. Now the question is how far above the center. So this is the target. How far above? So you will draw a line like this and rifle aiming at this point A, B, right? So basically AB length, which I call Y, is to be find out according to this question. Here is this is angle of projection, okay? Now to start with, what we have to do, first we have to connect the range. So use the formula u square sine 2 theta upon g. Range is 700 speed is 630 sine 2 theta upon approximately 10. Okay, or you can take 9.8 also. 10 is cancelled like this. So coming sine 2 theta is, this 7 will get cancelled 9 times. So 10 upon 9 into 63. This is what it is getting. Okay. Now as we know, this value is very small. Therefore we will have to do the approximation. So for a small value, sine theta can be written as 2 theta. So it will be 10 into 9 into 63. From here, theta become 5 upon 9 into 63. Now go in the main figure and see how much is tan theta, because y has to bring into picture. So tan theta equals to y upon 700, right? Approximately this is theta. So this theta is y upon 700. Which is equals to 5 upon 9 into this. Okay. Now rest is the simplification. So on simplifying this, we will get approximately, this is 6.1 meter. Okay, so the answer is D. In question number 36, particle of mass m is acted upon by a force F, given as F equals to RV upon T square. If this law is to be tested experimentally by observing the motion, the best way is to represent the straight line graph. See, the main line is straight line graph. So you need to have a straight line graph among these relations. Okay. So V and T are involved. Therefore, you have to express this in velocity and time only. Here is force, wherein there is an acceleration also. So we need to solve that acceleration. आप लिखोगे F equals to ma equals to R V upon T square. A will be written as dV upon dt. Then do the cross multiplication. So m into dV upon V will be written as R dt upon T square. This will be written as T square. Integrate both sides. So m into ln V equals to R into 1 upon T to the power minus 1 upon T. 1 upon T square is integrated as minus 1 upon T. Now in this case, you will see this term as y and you will see this term as x. Then you will get a straight line equation with the negative slope, right? So the graph that will come with the straight line is ln V and 1 upon T. So the answer is D. So in question number 39, there is a graph given for velocity and time for scooter and car. Okay. The difference between the distance traveled by car and scooter in 15 seconds, that we have to find. कार एंड स्कूटर के बीच का डिस्टेंस डिफरेंस, एंड देन द टाइम व्हेन द कार विल कैच अप द स्कूटर. So to catch up the scooter, distance traveled has to be equal for both. Okay. Now to start with point number 1. In 15 seconds, what we have to do? We have to find the area which will be the distance on VT graph, right? So for car, for scooter, how much is the area in 15 seconds? This is the rectangle which has a height of 30 meter and time of 15 second, right? So distance covered by scooter is 30 into 15. अभी रहने देते हैं, बाद में कैलकुलेट करेंगे. Similarly for car we will be taking a triangle. So distance of car is half into height is 45 into base is 15 second, right? So what is the distance traveled? It will be d scooter minus d car, and that is coming. So 30 minus 15 minus half, 45 into 15, taking 15 common from both, and this will give us 15 into, this will be 22 by 3, this is 7.5, and after multiplying we will get 112.5 meter. So this is the difference of distance at this point of time. Now question is, in second part, how much time it will take for car to catch up the scooter. Right now scooter is leading with this much distance, 112.5 meter. So after 15 seconds, because car is leading, so car will cover extra distance to make up this 112.5 meter. So far scooter has been leading with this distance, right? And from the figure, after 15 seconds, this is the portion which will be covered extra by car comparing to scooter. So this distance, this rectangular portion should be equals to 112.5 meter. So let us take this time which is after 15 seconds as t, and this height is already 15. So how much is the distance extra covered by car comparing to scooter? It is 15 into t. Now this extra distance covered by car will be compensating the extra distance which scooter was leading with till 15 seconds. That is 15 into 7.5. Now from here you will cancel out 15. So it is coming t equals to 5.7 second. This is 5.7 second after 15 second for the car to catch up the scooter. And therefore what is the exact time? So we'll have to add 15 plus 7.5, which will give you 22.5 meter second, right? And therefore answer is A. So in question number 41, a man in a car at Q is here, on a straight highway moving with the speed V, it is moving with speed V, and decided to reach at point P in the field at a distance D from the point M on the highway, right? Speed of the car in the field become half of highway, V by 2. So RP will be the distance covered with V by 2. What should be the distance Rn so that the time taken to reach the point P is minimum? Let us call this distance as x, which we have to find, and this total distance as d, right? Now in order to reach with the minimum time at P, this Q would have option to switch over from highway to the field at any point of time, like it can go like this, और R से थोड़ा आगे होकर के भी ये नीचे उतर सकता है, ठीक है? So here x is basically variable that will be deciding at which point what would be the x so that the time is minimum. So what we will do, we will first write time equation for the two part, that is Q to R and R to P, right? If T1 is the time here and here T2, then total time T will be written as T1 plus T2, And for t1, distance upon speed, distance is d minus x upon v. And for t2, this distance is how much? Rp is how much? Root under d square plus x square divided by velocity v by 2. That 2 will come in numerator. Okay. Now on what this time is depending? So it is depending on x. So we need to differentiate it and make it equals to 0. For t minimum, dt upon dx will be made 0. So start differentiating this equation. So dt का टाइम के साथ डिफरेंशिएशन करोगे 1 होगा. Now सेकेंड टर्म पे आ जाओ यहाँ पे, तो d का डिफरेंशिएशन 0 होगा और x का डिफरेंशिएशन dx अपॉन dt होगा विथ रेस्पेक्ट टू टाइम. ओके सॉरी, वी आर डिफरेंशिएटिंग विथ रेस्पेक्ट टू x ना. सो t का डिफरेंशिएशन होगा dt अपॉन dx. नेक्स्ट टर्म में आएंगे तो d का डिफरेंशिएशन तो 0 होगा बट x का डिफरेंशिएशन 1 हो जाएगा. सो इट इज माइनस 1 अपॉन v, देन 2 अपॉन v, एंड रूट का डिफरेंशिएशन होता है 2 रूट अंडर डी स्क्वायर प्लस एक्स स्क्वायर इंटू, फिर अंदर वाले को चेन रूल से डिफरेंशिएट करेंगे, वी विल गेट 2x, राइट. नाउ मेक इट इक्वल्स टू 0 एंड देन सिंप्लीफाई इट. सो 1 अपॉन v इक्वल्स टू 4 अपॉन v, सॉरी 2 कैंसिल, so 2x upon root under d square plus x square. This we cancel out. So 2x equals to d square plus x square. Do the squaring on both sides. And from here x is coming as d upon root 3. Fourth one is the answer. Now in question number 43, there is a race of two cars A and B which will start from the same point with the same initial velocity 0. They have an acceleration of a1 and a2, but A reaches t time less than B and finishes with v more velocity than B. B से ज़्यादा velocity के साथ A finish कर रहा है और B से कम टाइम लेकर के A finish कर रहा है, right? So let's make two paths. And this is the start point where A and B are. Both has initial velocity 0 and this is finish point. अगर B कैपिटल T टाइम लेता है और U स्पीड के साथ फिनिश कर रहा है, then what about A? A takes T minus small t time and its velocity is V plus U as per the question, right? The distance is same but different point of time. At different point of time they are covering this distance. So we have to make the relation, one of velocity and another of time, right? So we can use the formula v equals to u plus at. So for A, what we equation write? Final velocity v plus u equals to 0 plus at. So a1 into capital T minus t1. What I am using? V equals to u plus at. Okay, equation number 1. Likewise for B, use u equals to, means final velocity equals to initial velocity 0 into a2 into capital T. Now we can substitute capital T over here or u over the equation number 1. We will put u. तो v plus a2 into t equals to a1 into t minus a1 into small t. Do a little rearrangement like a1 minus a2 into capital T, a1 into t. Now keep the equation 3 in hand. Further write a relation of distance with the time using the formula s equals to ut plus half at square. Okay, so for A we will write v square equals to u square plus 2as, right? or S equals to ut plus half a t square. For A, we'll write d equals to half a1 into t minus t whole square, and the same d is for B, it is a2 into capital T square. This half will get cancelled. a1 upon a2 equals to t upon t minus t small t whole square. Take the root cover. a1 upon a2 equals to t upon t minus small t. Doing the cross multiplication, root under a1 t minus small t equals to root under a2 into capital T. Remember, we are going for capital T from this equation. How much is that coming? And so after solving this, we get this time, right? Now we will put this time in equation number 3. Okay. So what is equation number 3 is v equals to a1 minus a2, and then capital T is there. In place of this capital T, we are putting root under a1 t upon root under a2 minus root under a1 minus a1 into t, right? Now what we have to see over here is, you will see this expression a1 as root under a1 square like this, and a2 as root under a2 square. Now you can break it on a square minus b square. So after that, what we will get is root under a1 plus root under a2 into t minus बाहर में क्या है, तो बाहर में रूट अंडर a1 भी है. Okay, so this will be root under a1 into t minus a1 into t. It's like this. Okay. Okay, यहाँ पे साइन उल्टा होगा. ठीक है, मेक द साइन उल्टा, and then यहाँ भी साइन उल्टा होगा, but the rest of the solving will remain same. Root a1 and root a1 will become a1, जो कि minus a1 into t के साथ cancel out हो रहा है, and we are left with a1 a2 into t. This is our final result. Okay, a1 into t. B is the answer. So in question number 44, basically speed of the particle is to be find out when x, y and z is given as a function of time, right? So we have to differentiate x, y and z with respect to time, and then the velocity, speed means the magnitude of the velocity, right? That we have to do. So what will come? What is the speed on x-axis? Differentiate x dx upon dt. So here it is cos omega t minus a omega sin omega t. Okay, likewise, what about vy? It will be a omega cos omega t. देखो sin omega t है यहाँ पे, and vz, velocity on z axis is a omega only. Now the speed will be given as root under v square, vx square plus vy square plus vz square. So square of cos square and sin square is coming, which will become 1. So what we see here is 2a square omega square root cover after solving. So it is coming root 2a omega. Answer is C. In question number 45, two guns A and B can fire with the speed of 1 km per second and 2 km per second in all possible direction on a horizontal ground. The ratio of maximum area covered by the bullet by the two guns. Okay, now see, so gun can fire in all possible direction. So maximum area will be obtained when the range is maximum, okay, which occurs at 45 degree, okay, and this is the range will become radius and this will become area, okay. So area A1 or AA will be pi into range square. Range is here, area, radius. Now 45 degree, so what would be the formula? It will be pi into u to the power u square upon g whole square, taking sin theta as 45 degree. So what we see is area is proportional to velocity to the power 4, okay, because g and pi are constant. So area covered by A upon area covered by B equals to velocity of A and velocity of B whole to the power 4, which is given 1 by 2 whole to the power 4, and it will give you 1 by 16. D is the answer. So in question number 46, a VT graph is given, and at t equals to 0, x is given as 0, and it starts with velocity 0 also. So the question says, what is the position of the particle at t equals to 5 seconds? So simply displacement निकालना है और initial velocity तो 0 है. Now displacement is given as area, okay. So area up to 5 seconds. Area up to 5 seconds. This is 5 seconds. So you can see this trapezium. So we'll be using the formula half into height. Height is 2 into sum of parallel side. So ऊपर का जो parallel side है वो 3 यूनिट दिख रहा है और नीचे का parallel side 5 यूनिट दिख रहा है. So 3 plus 5 will become 8. So it is 8 meter. Okay. Now delta x का मतलब होता है x2 minus x1 equals to 8 और x1 तो 0 दे रखा है. So x2 means final position is 8 meter. Answer is B. So in question number 46, a particle moves from the position, ये position initial position दे रखा है, and this is x1 and this is y1 with the initial velocity vx and vy is also given, with the acceleration ax and ay is also given. What is the distance of the particle from origin at t equals to 2 seconds, right? So basically we will find new position of the particle, that is new position x and y at t equals to 2 seconds, and then we'll find the distance from the origin. Say this is your xy axis, so this will be the origin here, and जो point पता लगेगा वो a point अगर होगा, then this is the distance we have to find, which we will obtain by using Pythagoras theorem, right? So first calculate x and y. What formula we will be using on x axis? We will be using x equals to x1 plus ut plus half at square, right? X1 is the initial position on this, and we'll get after solving that as 20 meter. Okay, this is 10, this is 2, 12, and this is your 8. So 12 plus 8, 20. Similarly on y axis, you'll be using y1 equals to y1 plus uy plus half a t square on y axis. Okay, so now substitute from here. Y1 is 4, u initial velocity on y axis is also 4, and the acceleration is also 4. So 4 plus 4 into 2 plus half into 4 into 2 square, right? So this is your 8, 8 plus 4, 12, and 12 plus 8, it is again coming 20 meter, right? So x is also 20 meter and y is also 20 meter, and therefore this distance is coming as 20 root 2 using Pythagoras theorem. So OA is 20 root 2 meter. Okay, A is the answer. In question number 48, particle of mass m moving on a straight line has initial momentum p given, acted upon by a force F equals to kT in the same direction on the moving particle for the time interval of t. So in this case, speed will go up, okay, and therefore momentum has changed from p to 3p. Where k is constant, so what is the value of t? See, here the force definition is rate change of momentum. Force is dp upon dt, right? And so we need to integrate it. dp equals to force into dt, and force के जगह पे आप k dt रख करके kt into dt रख करके integrate करेंगे. Now when I put integration on the both side, particle has 0 time to t time, capital T time in fact, and the momentum will change from p to 3p. So on integration we get 3p minus p equals to half capital T upon this. So what we are getting is 4p upon k root cover equals to capital T. So root p upon k. Which one is the answer? A. In question number 49, passenger train of length 60 meter travel at 80 km per hour and another train travel at of length 120 meter travel at 30 km per hour. Time taken by the two trains to cross each other when they are moving in the same direction and in opposite direction. So see, this is the case of a relative in which if they are moving in the same direction, their velocity will be subtracted, and if they are moving in opposite direction, their velocity will be added. And how much is the relative distance they have to cover? They have to cover 60 plus 120. How? So say this is a train B और एक दूसरे को कवर अप करना है सेम डायरेक्शन की अगर मैं बात करूं. सो दिस इज A and this is where A has started overtaking B. Now after some time B also move and A also move, but suppose A has more speed, so A will lead and a time will come when A will be leaving B like this. This is the tail or the last box or bogie of the train A, which is leaving the engine of train B. Now in this case we will say that one has crossed completely the other train, right? Now how much distance has been covered by one train with respect to other? So if you think from the engine of A, right, कि वो कहाँ से कहाँ तक चला है, तो वो यहाँ से यहाँ तक चला है. ठीक है, ये जो इंजन है वो B को, मतलब जो भी B का लेंथ है L2 सपोज करो, वो कवर अप किया. उसके बाद ये वाला डिस्टेंस भी पूरा कवर अप करेगा अपना डिस्टेंस, तब जा कर के कहेंगे कि A जो है वो B को ओवरटेक कर रहा है. सो द टोटल डिस्टेंस ट्रैवल्ड बाय वन ट्रेन विथ रिस्पेक्ट टू अदर विल बी L1 प्लस L2. In this case it is 60 plus 120. So D relative is 200 meter. 120 plus 60. Same direction. So time taken for the same direction will be D upon V1 minus V2 mod. Okay. So it will be 200 upon 80 minus 30. That is coming 50. And unit is kilometer per hour. For converting it into meter per second, we'll multiply it with 5 by 18. But we are not going to solve it right now because we know that this values are going to cancel. Therefore, now if in opposite direction, the equation will be T upon V1 plus V2, that is 200 divided by, when we add the velocity, it is 110 kilometer per hour. We'll write it like this. So we'll have to divide this equation. So T same upon T opposite equals to 200 get cancelled. Everything is getting cancelled. We are getting like this, means 11 upon 5. D is the answer to this. Question number 51. There are two ships A and B. Okay, and velocity of A is given, and B is location of B with respect to A is also given, 80 km east and 150 km north. Okay, and the ship A is and B is sailing towards west with 10 km per hour. Okay, so in what time A and B will be at the closest distance? This is the question. Okay, so let us first figure out this. Okay, now in this case A is here at the origin, so A say, and this is your east, north, west and south. So ship B is 80 km east and 150 km north, so somewhere here this is B. Okay, 80 150 y पे है. Okay, and it is sailing in this direction, west में वो जा रहा है. ठीक है, velocity of B is along west 10 km per hour and A का भी velocity दे रखा है कुछ इस तरह से. What is the shortest distance between them? So what we will do here is we will bring one at rest. So A will be at shortest distance. So what we will do, bring A at rest. Okay, or you can bring B also at rest. So we are going to redraw the diagram with respect to A. So we'll have to give the velocity of A to be in opposite direction. So new diagram will be, this is B. B has its own velocity of 10 km per hour, but A has velocity of 30 km per hour on the left side, on the right side. So we have to give it in opposite direction. It will become 30 km per hour. Then the A also has y-axis velocity of 50. So we have to give it downside and it is 50 km per hour. So the sum total on x-axis is 40 now. Okay. And therefore there will be a resultant with which it is going away, and that resultant is somewhat like this. This is the path on which the ship B is moving and A is at the origin resting there. We will draw a perpendicular here. This x is the shortest distance between A and B now. Okay, so what we see here, angle पता कर लेंगे यहाँ पे. We know this distance also. How much was that distance? It was 150 on north direction, and on x-axis it was 80 km. Okay. Now first is to find this angle theta. How much is this theta? So this theta is 40 upon 50, 4 upon 5. Now this angle will be 90 minus theta, this angle will be 90 minus theta, and this angle will be theta now. Now if I call this position as D, so we have to find D, AD, to find the X. Call this point C. Now from the triangle BCD, I can apply tan theta equals to DC upon BC. Tan theta is 4 upon 5 equals to DC. DC means that we have to find. BC means 150. Okay, this is 30, and so DC is coming 120 km, right? So basically D point is on the left side, means it is like this. Okay, and D point is here now. After calculation we got to know this. Okay, and यहाँ से हमें ऐसे perpendicular drop करना पड़ेगा फिर. This will become X. Rest, if this angle is theta, then this is 90 minus theta and this angle is still theta. Okay, so now focus on X. For that you need to know this term. Okay, call this origin O. तो हमें क्या चाहिए? हमें चाहिए OD. Okay, और अभी हमें DC या DC पता लगा है. So DC में से OC को माइनस करेंगे तो OD मिलेगा. DC minus OC is this, that is 120 minus 80. This is giving you 40 kilometer. Now in triangle ODE, you will apply what? Sine or cos? You will apply cos theta. Cos theta equals to OE upon OD. Now because we know this tan theta, therefore we can find cos theta also. So OE, which is the shortest distance, is OD cos theta. So this OE will be written as OD into cos theta. OD is 40 and cos theta will be 5 upon root under 41. When you solve it, we will get it approximately, means 200 upon root under 41 can be taken as 6.4, and after solving it approximately we will get 3.2 kilometer, 3.2 r, right? And so D will be the answer to this. So in question number 52, a particle start, means initial velocity is given 0 from origin, from rest, and with the constant acceleration and in the positive direction of x-axis. So हमें AT, VT and xt graph को identify करना है. Constant acceleration, so A is correct, starting from 0 velocity, and it will be a straight line, V equals to U plus AT, so B is also correct. C is not correct because it is showing the retardation, right? It is showing the retardation and then it is becoming constant, which is not the case. And D is not, and D should be something like this. It is correct because means we don't have any other option, like A and B is not there in the option, and C for sure is not, should not be the answer, right? And D graph should be a little correct like this, so that the slope will be 0 and velocity should be representing initially 0, okay? But if we have to choose best of the 4, D will be the answer. Now in this question 54, a ball is thrown vertically upward from the ground. Correct momentum height diagram will is. So momentum is m into v. So basically you have to see v versus h diagram. Now since the ball is thrown upward, so its velocity is positive but it is decreasing, and starting from h equals to 0, when h grow up, velocity becomes 0. At this point velocity is 0. After this height h, ball will come down, so velocity will become negative. So first half it should be positive and second half it should be negative, right? Which is given in the graph C and B, right? D is showing पहले निगेटिव ग्राफ वेलोसिटी है, ए भी निगेटिव वेलोसिटी को पहले रिप्रेजेंट कर रहा है. नाउ इन दोनों में से कौन सा होगा? सो फॉर्मूला होता है v स्क्वायर इक्वल्स टू u स्क्वायर माइनस 2ah का. सो v स्क्वायर एंड h कैन नॉट बी a straight line, right? So B cannot be the answer. C will be the correct answer to this. In question number 55, x of a particle is given. When the acceleration is 0, find its velocity. So you need to differentiate twice. X is given at plus bt square minus ctq. Okay. From here, once you differentiate it, you will get a plus 2b minus 3ct square. Again you differentiate it. We will call it acceleration f because a is already there. 2 minus, sorry, here it is 2bt. So 2b minus 6ct. Okay. Now at the acceleration has to be 0, so make it equals to 0. So time will become b upon 3c. At this point of time, what is the velocity? So put in equation number 2, velocity equals to a plus 2b into b upon 3c minus 3c into b square upon 9c square. Okay, so it is coming